A very good morning to one and all present here. Today I am going to deliver a topic about electrical drives. A system which employs for motion control is called drive. An electric motor which employs for motion control is called electric drive. An electrical drive which is driven by some energy. The source of energy may be anything like wind, water, oil, steam, solar or electricity, etc. When the source of energy is electricity, the drive is called electric drive. In any drive system, we take some output in terms of energy or work done. Utilization of electricity for driving the mechanical system employs the use of electric motors, which gives an output in terms of mechanical energy. These electric motors are DC motors, synchronous motors or induction motor. It may be AC motor or DC motor. Many industrial applications requiring rotating electric drives are normally capable of speed control, and often it requires an equipment to attain a versatile and smooth speed control and make the motor to operate at a desired specific speed torque characteristics. These drives are characterized by the nature of speed torque characteristics such as constant torque drives and constant power drives. These are sometimes characterized by the type of motor used in the drive, that is DC and AC drives, making use of DC and AC motors respectively. Types of drives or classification of drives. The types of drives used in industries may be divided into three types: individual motor drive, group drive, multi-motor drive. The name itself is indicating what type of drive it is. Individual motor drive. In individual motor drive, a single electric motor is used to drive one individual machine or an individual load. The machines can be placed in any desired position and can be moved very easily. The machines can be built as an integral part of the complete system, which results in a good appearance, cleanliness and safety. For the purposes where constancy of speed and flexibility of control is required, such as in paper mills and textile industry, individual drive is essential. The group drive. By group drive is meant a drive in which a single electric motor drives a line shaft by means of which an entire group of working machines may be operated. It is also sometimes called the line shaft drive. The line shaft is fitted with multi-stepped pulleys and belts that connect these pulleys and the shafts of the driven machines serves to vary their speed. The drive is economical in consideration of the first costs of the motors and control gear. A single motor of large capacity costs less than the total cost of a number of small motors of the same total capacity. Rather than using a single motor of large capacity, we can use a number of small motors. The efficiency and power factor of a large group drive motor will be higher provided it is operated fairly about 10% overload when being driven by group drive. This form of drive has become obsolete nowadays because of its following drawbacks and objectionable features, and the modern trend is to employ individual and multi-motor drives. In group drive, speed control of individual machine is very cumbersome using stepped pulleys, belts, etc. Owing to use of line shafting pulleys and belts, group drive does not give good appearance and is also less safe to operate. In group drive, Since machines have to be installed to suit the layout of the line shafting, as such flexibility of layout of the various machines is lost. Also, it is not possible to install any machine at a desired place. The possibility of installation of additional machines in an existing industry is limited. If at any time all operations are not required, the main motor will work at low capacity and therefore operation efficiency will be low. The breakdown of large single motor causes all the operations to be stopped because all other motors are connected with the main large single motor. Multi-motor drive. It consists of several individual drives, each of which serves to operate one of many working members or mechanisms in some production unit. Such drive is essential in complicated metal cutting machine tools, paper making machines, rolling machines and similar type of machinery. The use of multi-motor drive is continuously expanding in modern industry as their advantages outweigh the increase in capital cost as compared to the group drives. The use of individual and multi-motor drives has enabled the introduction of automation in production processes, which in turn has considerably increased the productivity of various industrial organizations. Complete or partial automation helps to operate various mechanisms at optimum conditions and to increase reliability and safety of operation. Various type of driven equipments, or we can sometimes call as load: pump, fan, compressor, conveyors, mill, crusher, crane, hoist, traction. These are all the types of loads which can drive by electric motors. Amongst motor used in any modern plant and industry, the maximum number of motors used is three-phase induction motor because of their cheapness, robust construction and satisfactory performance. Their maintenance in service is also easier as compared to other types of electric motors. The torque speed characteristics, inertia and duty cycle of load will mainly determine the electrical characteristics and rating requirements of the driving motor. Duty cycle is nothing but the on period of the drive divided by the on period plus off period of the drive. The proper selection of motor rating and design will result in a minimum motor cost for a specified motor life expectancy. Torque speed characteristics, inertia and duty cycle of load. The selection of undersized motor for low motor cost, however, may result in overloads and a consequent reduction in motor life. Additionally, in actual practice, motors are subjected to abnormal operating conditions because of system inability to maintain the normal operating conditions when some accidents or faults take place. Any form of abnormal operating conditions may affect the performances, high losses and life expectancy of the motor. The degree of deterioration depends upon the magnitude and nature of abnormal conditions. Therefore, the abnormal operating condition may also be taken into account in design stages so that its withstand capability is increased. Paper protection will also be employed to save motor against severe damage. Thank you.